Good afternoon. Hope you guys are doing well. Um, if you're online, can you hear me?
Yeah.
Perfect.
Yes.
Going to get your graphing calculators. Go and get your notebooks. Go and get your math packets. Open page 4 and 5. Going to open this one. Open page 4 and 5. So it's been a few weeks when we did the trig. That was the week number 2. We did the trig, the trigonometric functions, the identities, and we did the a little bit on inverse and stuff like that. We're going to continue with that, okay? We're going to continue with the topic. It's a pretty heavy topic. You get between 4 to 6 questions on this range of topics, and you have to be very, very good at this, okay? Next, we're going to discuss is directionality. Directionality in the XY plane. What I would like you guys to do is not to worry about writing anything. Just listen and ask questions, of course, and then I'm going to give some time for you to write down. You got to know the fundamentals of this, okay? So, this is our XY plane, the coordinate plane, x-axis, y-axis, you know that. So based on how the angle is formed, there is 2 types of directions in we study in XY plane. Counterclockwise is called the terminal direction, also called the positive direction. The clockwise is coterminal, and it's a negative direction. Make sense? Simple. So it's a pretty simple concept actually. So for example, if I draw an angle here, always to the x-axis, so let's say this is 135 degrees. When we talk about 135 degrees, so far we didn't care about the directionality. Now we're going to start about the directionality. So look at the arrow we draw. This is your terminal direction, positive direction. Sounds good? Or the other way around to do it is the coterminal direction. Of course, you guys know it's a circle, 360 degrees. So it should be what? Minus what? Get your calculators. Do 360 minus 135. Sorry? 225. So from today onwards, when we talk about an angle, you ask what direction it is. Sounds good? Both mean the same, of course. Both mean the same, but it is important in trig. Sounds good? This leads to a new topic called reference angle. Reference angle. A reference angle is a reference to only x-axis. Okay? Always x-axis. And it's always positive. So reference angle is always going to be positive. It's always going to be between 0 and 90 degrees. Alright? So reference angle is an angle that is referenced to the x-axis, always a positive degrees, and always between 0 and 90. Sounds good? So for example, let's go back to this 135 degrees here. Let's go back to this one. So if I draw this angle, this is positive 135 degrees. And if I ask you, what is the reference angle of this? So what we do is we reference to the x-axis. So this is my x-axis. This is my reference angle, RA. And remember, doesn't matter, it's always going to be a positive, irrespective of the direction of the arrows. Sounds good? So this is 180 degrees, this is a linear pair, so if this is 135, so the reference angle will be plus 45 degrees. Sounds good? So let me repeat. When you talk of reference angle, directionality does not matter because it's always going to be positive. So that means you take the absolute. Second, it's always between 0 and 90. Sounds good? And always reference to x-axis. Good? Gonna write on this. And then see if you have any questions, ask. The problems can be pretty tricky on this, so we'll get to those. All right, let's get to problems now. Let's see. This is kind of harder one to begin with, okay? And I'll give you guys enough time for you to do it. Once you're done, either you do the thumbs up if you're online, if you're here, just do the raise the hands and put it down so I can know. Here you go, first question. What is the reference angle of negative 1,344 degrees? Let's call it as 1A, 1B. Give at least one angle for terminal and coterminal angles for negative 1,344 degrees. Take your time, go. Understand the question first. Again, I asked you if you're done. If you're here, do the hand raise. If you're online, do the thumbs up. 6 online students. Okay. All right. How many are confident their answer is correct? 1. How about online students? 1, 2. Okay. Let's get started. Let me get my calculator here. And you may have to help me with calculator as well. So what I'm going to do is I'm going to draw my XY plane here. And we have negative 1,344. So it's negative. So one circle is negative 360, right? Second is negative 720. Third is what? Negative 1080, right? Am I right? Come on, guys. Let's do it quick. I don't want to waste time. Okay, 1080. So we're left with how much? 264. So 264. This is 180. 84. Okay, something like that. Here you go. So this is, and I'm going to draw in dotted line so we can actually kind of reference the dotted line. All right? How many got this drawing correct? If you didn't draw, you would make silly mistakes. I've seen 1, 2, 3, 4. Okay. You got to draw any geometry-based problems. Sounds good? It's a pictorial representation. You got to do that. Yeah, it may take a few seconds, worth it. Okay? What is a reference angle? So reference angle is always to x-axis. So this is my reference angle. So how much was that? Negative 264. So this was what? 84. So the reference angle is positive 84. Am I right? I think so. Yeah, 84. Okay. The question is, give at least one angle of terminal and coterminal angles. Well, this will be an example of a terminal direction. So it will be what? 84, so 180 minus 84, what, 96? Okay, that's positive 96 degree is a terminal direction. Coterminal would be, let's go with negative 264 itself. So it will be coterminal. How many got reference angle 84 correct? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. How many got, if for the terminal and coterminal, how many got 96 and negative 264? 1, 2, 3, 4, 5, 6. Okay, a lot of people. Is there any other answers you have for terminal and coterminal? Well, this would itself would be a negative coterminal, but I wanted to give at least one angle other than this. That's what I meant. Does anybody else have any other examples of a coterminal and terminal for this angle? Come on. Of course, this would be easy, is to go with these two. But you didn't have to go with these two. Okay?
Negative 984.
Negative 984. Oh no, hold on. Negative 984. Okay, so that would be this one then. Yeah, that would be this one. Second revolution. Okay, That's okay.
And you can do negative 624.
Yeah, you can. See, third revolution, right? Yeah. But you get the point? You guys good? Any questions on this?
Excuse me?
Sorry?
I had a question. I didn't know, how did you find, could you please explain how you found the reference angle? I didn't understand that.
Okay. Remember, for the reference angle, it has to be between 0 and 90 degrees, right? So what I did was, I went through enough revolutions where my negative 1344 got completed here, okay? Which is in the second quadrant. In the second quadrant, this was negative 264. So this is negative 180 and negative 84 to get to this particular point. So the reference angle is for the x-axis, which is 84 degrees here, positive.
Oh, okay. Thank you.
And I actually want you guys to write down this one. And this is a shortcut, okay? This is for reference angle. This will tell you the direction you have to go for the reference angle for each quadrant. So first quadrant, second quadrant, third quadrant, and fourth quadrant, because it always goes for the x-axis. So this is just a hint you can use for reference angle. How to draw the direction of the angles. You guys good? Any questions? Open page 6 of the math packet. At the bottom of page 6, read radians and degrees, please. Go. 2 minutes. So we're going to do the unit conversion. Just like when we talk about length, we talk about feet, inches, and so forth, right? 1 feet is 12 inches, is a conversion. Just like angles have 2 units. So there's 2 units for angles. Well, you're used to degrees. Your calculator should be in degrees mode. And there's another called radians. Just like 1 feet is 12 inches, there's a relationship. There's also a relationship here. 180 degrees is pi radians. Sounds good? 1 feet is 12 inches. Similarly, 180 degrees is pi radians. First up, So let's go back to XY plane here. 0 degrees, 90 degrees, 180 degrees, 270 degrees, back to 360. Sounds good? So let's do the radians now. Of course, this will be 0 radians. This will be pi by 2 radians, right? Half of 180. This will be pi radians. What should be this one? Quickly. 3 pi over 2 radians. And this should be 2 pi radians. Sounds good? So, when we draw XY plane, it can be in radians or in degrees. Okay? Now, let's talk about so we have two circles here. Okay? One has smaller radius, another has a larger radius. What is the common between these two circles?
Are they proportional?
Don't know. What is the common between two circles, even if the radii is different?
Oh, they both have the same center.
If they have the same center, those will be called concentric circles. This is what a concentric circle would look like. This is concentric circles. Same center point, different radii. But how about these two? It's a simple question.
360 degrees.
Yeah, good. Both have 360 degrees, right? Circle, small or big, the angle is 360. So what is in radians? 2 pi, right? So, look at the formulas for circumference. 2 pi r. Now you can realize where the 2 pi comes from. Comes from the 360 degrees. So circumference only depends on radius. The angle remains constant. This is how the formula circumference, which you guys been studying for a long time, actually came to existence. Is the circumference is proportional to radius, but is bound by a constant called 2 pi, which is the angle. Sounds good? And this is, of course, is concentric circles, which sounds good? Okay. Any questions so far? Okay. Go ahead and write on this. All right, let's get started. First question. Convert 2.25 pi radians to degrees. Expect this question around 40. Again, let's do the same rules. Just do the hands up and thumbs up, and so that I have an idea. 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right. Of course, if you know the conversion, it's a pretty straightforward problem. So 2.25 pi radians. So as you know, pi radians is nothing but 180 degrees. So it's 2.25 times 180 degrees. $405 degrees. How many got 405? 1, 2, 3, 4, 5, 6. Okay, a lot of people. Any questions? Second problem. Convert 84 degrees to radians. Please note, both of these questions were an ACT real test. So that's why I'm giving the exact numbers. Convert 84 degrees to radians. All right. Now, one of the things, I don't know if I've told you guys this, but I'm going to tell you this. This is something you need to remember for ACT, especially true for math. When you read a question in ACT math, when you're done reading, before you solve the question, you directly have to look into the solutions to find out what format answers they use. Sounds good? That will tell you whether they're looking for fractions, they're looking for trig, they're looking for radicals. So skimming or scanning the answer choices or having an idea of what the format is, that will help you. Especially true for this particular problem. So I want you to listen to this. So 180 degrees is pi radians. So it's a simple direct conversion problem. So 84 degrees, this is degrees. And I'm multiplying with, to get to radians, pi radians is 180 degrees. So as you know, the units have to cancel. And you get the answer, right? Here's what I want you to be doing. Get your calculators, please. Everybody, get your calculators. This will be a good practice. All right? Do 84 divided by 180. Okay, you get some decimal, whatever it is, right? Then do math 1, enter to convert into fraction. I repeat, math number 1, enter. You get a fraction form, 7 over 15. So this will be 7 pi or 15 radians. And this is exactly how they had given the answer. I want everybody to know how to convert a decimal to a fraction in a calculator. You have a decimal. If it's a terminating or a repeating decimal, you do math 1, enter. Now, so I see this question, and if this is the answer choice, of course I'm done here. But sometimes, very rarely though, they convert this to a decimal. We know pi is 3.14, right? That doesn't change. So I can do 7 times 3.14 divided by 15, which is 1.47 radians. I've seen this only once when I've been teaching for a while, where they put pi as 3.14 and convert it to completely a decimal. Sounds good? But I would like you to focus on this. All right? Any questions? Any doubts? Any comments? Yeah?
It's just 0.47 radians.
No. 7 times 3 is 21, so it has to be more than 1.
That's
Yeah.
Why do they on the ACT focus more on 7 pi over 15?
Good. First of all, this is irrational because pi is irrational, so it's easy. Second, I don't need to have a calculator to get to this point, but I definitely need a calculator to this. Make sense? But yeah, I don't worry it at all. For me, whatever you want, okay. But always, fractions are much more concrete than having a irrational decimal and stuff like that. So yeah, but it doesn't bother me at all. Either one is fine. I have a question. Could you please let my... Okay, what's going on here? Somebody has a comment. Okay. Any other questions? What I want you guys to do is to review whatever we did till today, word by word. 5 minutes, go. Go back to your notes. Go through everything what we did today. The last thing I want is to forget what we have done, okay? All right. We're gonna move to a new topic today. Circles. Okay, but I know Aubrey is gonna cover some more circles. She'll cover the easier topic. I'm gonna cover the harder topics. All right. Again, you don't have to write anything. Okay. All right. Let's get started here. First, what is this line called? And I want you guys to participate. I've not been impressed lately. It's too much quietness. Same with online students as well. Guys have to participate.
Arc length.
What's that?
Arc length.
Mm-hmm. Yeah, it's okay to be wrong. I'm okay if you're wrong. Gotta participate. This is 9th grade geometry. Basics. Come on. Seriously? It starts with C.
Is it a secant line?
Is it a chord?
Chord. Somebody said, who said secant?
That was me.
Okay, let's see, who's that? Yeah, okay. Well, as you use the word secant, I'll tell you what happens, the difference between chord and secant. Look at this. This line becomes a secant. So what's the difference between a secant and a chord?
Secant extends beyond the circle.
Secant is a line, and a chord is a line segment. Remember the first day of geometry you learned that? That's where you learn. So this is a line segment. This is a line. Good? So this is a chord. What's the longest chord? Come on, you guys should know these things. What's that? A diameter is the longest chord. Almost touching the center point, right? Excellent. Yeah, but I expected you guys to know this though. It's easy stuff. Next. I'll draw a line from center point at 90 degrees to bisect this chord. Okay? I'm going to ask you a first question. So what is this line called? What's a technical name in geometry for this line now? I'm okay if you're wrong, but I want to participate. It's at 90 degrees and it's bisecting this line.
Chord bisector.
Good try. This is a perpendicular bisector. Heard that term? Perpendicular? So the first rule to remember in chords is a line drawn from the center point to the chord at 90 degrees bisects the chord. So this line becomes a perpendicular bisector. And the real reason you have to know this is, oh, by the way, what is this line called? Radius, right? So this is radius. So if I know the information of the chord and this distance, I actually can find the radius using Pythagorean theorem. Sounds good? The other way around is if I know the radius, I can find the chord distance. Good? Next. Oh my God, this is horrible. Could have drawn that better. It's okay. What are these lines called? Simple.
Sectors.
This is called a sector. Yes. But what are these lines called? Radius, radius. Right? So, two radii forms a sector. Sector is a piece of the circle. And the angle it forms, let's call it as theta, is called central angle. So a central angle is formed by two radii, forming a sector. Question, what is this line called?
It's an arc.
It's an arc.
Circumference?
What type of an arc? There are two types of arcs. This is called a minor arc. So the remaining becomes
Major.
major arc. So minor arc plus major arc is equal to
360.
360, or also called as, also called as,
2 pi.
also called as circumference. So minor arc plus the major arc is equal to circumference, but the circumference can be 2 pi r in terms of distance, or it can be 360 degrees in terms of angle. So an arc can be an angle, or arc can be a distance. Make sense? So if this is theta, this will be theta. So the major arc becomes 360 minus theta. Make sense? So this is theta, this is theta, this becomes 360 minus theta. Go ahead and write on this. I don't want you to focus on writing, I want you to focus on learning. What does it mean to me? Does it make sense? That's important. Writing is easy. That's good so far? Any questions, any thoughts, comments? All right. I want to make a comment, so I think this will be very helpful for you guys. So logic remains simple. Just remember, when we talk about arc, arc is a fraction of the circumference, right? Simple, it's a fraction. We talk about a sector, sector is a fraction of the circle, right? Keep it simple, it just is a fraction. And the fraction is decided by what? It's decided by this angle, right? The denominator is 360, that doesn't change the whole thing, right? More the angle, larger the sector. So the fraction is theta divided by 360, that decides the area or the arc itself. Make sense? Let me give a juicy problem, okay? Try this. Question number 1. This is a good one, okay? if somebody has an answer, I want to make sure you unmute yourself and tell me your name.
Would you take the answer in decimals?
Doesn't matter. Anything is fine. Anybody? One. Anybody online? No answers? Two, okay. Three, let's see. Avery, what's your answer?
For which one?
Well, let's start with the distance AB arc.
I had around 5.5 inches.
Okay. How about anybody matching that? I don't know the answer, so I'll have to do it. So, Chance, what do you got?
For the ABR length, I got 0.226 inches.
0.22. All right. 9.53. Okay. We're all over the place. Great. Right? That's how it starts. That's how you have to try. Mistakes happen. Now you have to learn. Okay? There can be only one correct answer. Put your pencils down. Let's do this. First thing first. So this line is drawn at 90 degrees, so it's gonna bisect the chord of 24 inches. So this becomes 12, and this becomes 12. Sounds good? Next, I'm gonna use this to find the radius. Okay, this is my radius. So that it's 5, 12, this should be 13, because 5, 12, 13 is a Pythagorean triplet. If you don't know that, you'll have to do a squared plus b squared and all those things. So I know the radius is 13. That means I know circumference is 2 pi r. So it'll be 2 pi times 13, 26 pi. First question, how many got to this point, 26 pi? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Right? That's the first step. Then, I told you that this arc is a fraction of the circumference, and the fraction is decided by the central angle, which is my theta. So, arc AB is equal to circumference, which is 26 pi. This is the entire thing multiplied by the fractions, which is decided by the central angle. Right? Circumference times what fractions. So get your calculus, do this for me. 26 times 3.14 times 42 divided by 360. 9.552 inches. And I believe Nathan, you had that one. Good, excellent. Did anybody else have 9.52? Come on, guys. Sector AOB area. So what's the area of the circle? Pi r squared. Pi, radius is 13, so 13 squared. This is the entire circle. Again, the fraction remains the same, 42 degrees divided by 360. The fraction doesn't change because the central angle doesn't change. So it's 169, 13 squared is 1 times 3.14 times 42 divided by 360. 61.9 inches square. Did anybody get that one? No? If you got this one, Nathan, you should be getting this one. It's pretty simple. Unless I type it wrong. Let me try it again. 13 square times 3.14 times 42 divided by 360. Yeah, 61.9. Questions? The key step is here. This is the key step. This is easy. And of course, this is my sector here. Questions, doubts?
I have a question.
Yeah, please.
I didn't understand why you put the fraction for finding the sector AOB. Like you put the 42 divided by 360. Like I didn't understand why you did that.
Okay. Remember though, to find the arc length, this arc here, this arc is the fraction of the circumference. And the fraction is decided by this angle, which is 42 divided by the entire thing is 360. That's a fraction.
Oh, okay.
Anything else? Go ahead and write down. You should be able to do this problem blindly once you learn this concept. This is a very important concept in ACT. Take a few minutes break. Aubrey will be here. I'll see you guys next week. See ya.